Mean drift velocity is often a difficult subject for some students. It is also covered in all of the new specification physics A levels. This means that it's essential that it's learned correctly. The free electrons in this copper wire, when a charge is added, will travel slowly towards the positive electrode. To be able to work out the mean drift velocity, you will need to know the cross-sectional area, the charge of an electron, the current, and the number density. This is the equation which is used to find out the mean drift velocity. The number density, the current, or the cross-sectional area. You should already know the elementary charge of an electron. In the equation, I equals current, which is measured in amps. N equals the number density, which is the number of free electrons per meter cubed. A equals the cross-sectional area found using pi r squared, and V equals the mean drift velocity measured in meters per second. And below is the different ways that the equation can be rearranged. Materials can be placed into three different groups based on their resistance. Semiconductors and insulators have a very high resistance, whereas conductors have a low resistance. Conductors have a very high number density, insulators have a much lower value, and semiconductors are between the two. This can be explained using band electron theory. A common question that's usually asked is if a light turns on seeming instantaneous, how fast do the charge carriers travel? Despite it seeming that the electrons have rushed from the switch to the lamp, they actually move really slowly. The reason that the light turns on really quickly is because the free electrons repeatedly collide with the positive metal ions at the same time. Thanks for listening.